Mr. Fritz here. We're going to talk about solving compound inequalities, and we're going to do some notes. So please follow along with these notes on your piece of paper, and let's dive into this. A couple things to start off. Let's talk about some notation. We have two different kinds of compound inequalities. We have or inequalities and we have and inequalities. When we or inequalities, the symbol that means or looks like a big U. So you could see something that looks like, this means or. You could see something that looks like x is greater than 5 or x is less than 2. That would be how you would see that show up. And one thing to keep in mind with these or inequalities is that either line must be true in order to have an or inequality. When we end up combining two different lines and two different inequalities, like we did in class the other day, something like this, an or inequality means that either one of these lines can overlap with the other. They don't need to have both two lines stacked on top of each other in a or inequality. If you compare that with an and inequality, the symbol that means and is kind of like an upside down U. Imagine this, it kind of looks like an A. That helps me remember that this is the and inequality. So you could see something that looks like x is less than 5 and x is greater than 2. Or you could see something, usually when we talk about and, we can also just write this in one string. So we could say 2 is less than x, which is less than 5. This is kind of like an an and inequality that doesn't even use the and symbol. And for the and inequality, for the and inequalities, we were looking for where both lines are true. So in an and example, if I were to look at an inequality that looks like this, the part of this inequality that is true or is actually part of the solution set is only where I have both lines overlapping. So that's true here, whereas for the or, all of this stuff is true as long as I have just one line. So let's see some examples of how to use these together. I want to solve this compound inequality. So since this is an or inequality, I'm going to treat each individual inequality like it's kind of two separate inequalities, and then I'm going to combine them together. So let's start off with red for this one. I'm going to subtract 1 from both sides. So I have 2x is greater than 14. Then I'll divide both sides by 2, and I get x is greater than 7. I'm going to put that on my first line here. X is greater than 7 is going to be my first inequality. And let's pick blue for my next inequality. I'm going to subtract 3 from both sides. I'll get negative 3x is greater than or equal to 18. And then we'll divide both sides by negative 3. And so I get x is, now remember I have to flip my inequality symbol since I divided by a negative. So this is going to be x is now less than or equal to negative 6. So I have x is less than or equal to negative 6. Now let's graph both of these inequalities. So over here I have an inequality of x is greater than 7. So let's just put 7 here, let's put 8 here, and my inequality will look something like this. It's an open circle, and it's pointing to the right. And for my blue inequality, I have x is less than or equal to negative 6. So let's make this negative 7. Let's make this negative 6. And this inequality is going to look like a filled-in circle, and it's going to be pointing to the left, all values less than negative 6. And since this is an or inequality, I'm going to, my final solution set is going to be wherever any of these arrows or lines overlap. It doesn't look for just where both of them are, but where any of them are. So if you can imagine, if I kind of lay these right on top of each other, they're kind of pointing forever in both directions. So in this case, my final solution set, let's actually do that in another color, in green. My final solution set, if I lay these down on top of each other, there will always be a line somewhere. So really, my solution set is all real numbers, we call this. Oops. since when I overlap these two lines, it points both directions forever, my x could really be anything, and one of these equalities will be true. Let's take a look at another example. Here is an OR inequality again. And this time I'm going to, let's solve this one first. I can distribute the 1/2. And so I get 3/2x minus 1/2 times 8 is 4. So that's less than or equal to 2. We're going to add 4 to both sides. And I get 3/2x is less than or equal to 6. Now we're going to multiply both sides by the reciprocal to cancel out that fraction. So this is going to cancel the 3's, cancel the 2's. Over here I have x is less than or equal to. And if I multiply these two fractions together, that's going to cancel the 6 reduces to a 2 and the 3 reduces to a 1. So that's going to be a 4. So x is less than or equal to 4 will be my first inequality. And then I have my second inequality. I'm going to subtract 1 from both sides. So I get negative 2 minus x is less than 4. This negative is kind of like a negative 1, so I have to distribute that negative 1 to both of these terms. So that becomes a negative 2 plus negative times a negative is a positive. So plus x is less than 4. And I'll add 2 now to both sides, so I get x is less than 6. So let's see, in blue I'll graph the top one here. So if I want values less than 4, let's graph 3 and 4, and I want to be less than or equal to 4. And actually, why don't I do this? I'm going to use these values together on my number line. So let me redo that one. Since I'm going to be using, oops, I went a little too far there. Since I've got a 4 and a 6 in my two inequalities, let's keep 4 and 6 in both of these inequalities. I want values less than or equal to 4. So that's going to be filling in the circle here and moving less than 4. And in my red inequality, I'm still going to use 4 and 6. And I want values just less than but not equal to 6. So I have an open circle, and my arrow is pointing to the left. So my full solution set, since this is an OR inequality, I want any space where any of these arrows are. And it looks like that's going to be beginning at 6 and moving all the way to the left. As long as I move to the left from 6, I will have at least one arrow in this area. So my solution set is that x is less than 6. Kind of takes care of all of these inequalities together. So this is going to be an AND inequality. I don't see the number or the symbol for AND in here, but because this is one compound inequality with kind of two parts to it, here's like one inequality, here's a second inequality, we're going to treat this as an AND inequality. So as long as you remember that whatever you do to one side, you do to the other side, will be just fine. This is kind of a lot like normal solving algebra problems, but in this case, I don't have just one side and two sides. I kind of have like three sides. So if I add a 3 to the middle of this inequality, I have to add a 3 to this 9, and I have to add a 3 to that negative 11. So over here I'm going to get negative 8 is less than 2x, which is less than or equal to 12. Next up, if I wanted to divide, if I wanted to divide everything by a 2, I'll get negative 4 is less than x, which is less than 6. So I really have two inequalities, and you know what I'll do is I'll say that this is kind of like one inequality. Negative 4 is less than x. And my second inequality is kind of like this right here. X is less than 6. So why don't I do this? Since I'm dealing with a negative 4 and a 6, I'm going to put the negative 4 and the 6 on both of these number lines. And then let's graph each of them individually. So I want wherever negative 4 is less than x, or I can kind of read that as x is greater than negative 4 if I just kind of reverse the order of this. So I'm going to have an open circle on negative 4, and I'm going to be moving to the right here. For my green, I've got x is less than 6. So that's going to be, again, an open circle, and it's moving to the left. Now, since this is an AND problem, I'm really looking for where I have an overlap between both of my lines. And that's going to happen in this area that I've just diagrammed. So my final solution set is going to be an open circle. Since I have an open circle here, I have another open circle on 6, and this is, I guess, from -4 to 6. And I'm going to have an overlap of 2 lines everywhere in between these 2 points. So my final solution set is, I could do this 2 ways. I could say x is greater than -4 and x is less than 6. Or I can write this as -4 is less than x, which is less than 6. Let's try one more example together. Here's another AND. And you can tell it's an AND because I have kind of 2 pairs of inequalities together once again. So just like we did last time, we're going to have to solve by doing something to each side of these 3 sides of this inequality. So why don't I first actually distribute this -2 to make my life a little bit easier. I've got a -14 is less than -2x minus 2, which is less than -8. And now let's add 2 to every single side of these inequalities. So I get -12 is less than -2x, which is less than -6. Next, let's divide everything by -2. Divide everything by -2, divide by -2. So I get a positive 6. I have to flip both of my inequalities since I divided by a negative, so that I get 2 inequalities. I have x is greater than 3, and I have 6 is greater than x. Or I might even write this as x is less than 6. And so let's graph both of these. And then again, just like we did before, let's use a 3 and a 6. Let's use a 3 and a 6, since those are the 2 numbers that I'm using here. And then we'll use a 3 and a 6 in my final solution set. In the green, I've got x is greater than 3. So there's my open circle, and I'm pointing to the right. In the red, for my x is less than 6, I have an open circle, and I'm pointing to the left. And again, since this is an AND inequality, I'm looking for the period of overlap, and it looks like it's going to be right here in this box. So my final solution of my compound inequality is going to go from 3 to 6. And it's not including 3 and it's not including 6 because one of these does not include positive 3, one of these does not include 6. So my final solution set, you can write 2 ways. I could say x is greater than 3 and x is less than 6. Or I can just say x is less than x, or excuse me, 3 is less than x, which is less than 6. So there you go. Hopefully these notes are helpful. Please review them and go back if you need to check on anything. And good luck with the rest of the practice.